Hey, everybody, and thank you so much for joining us on this 44th community call, where we are focusing on the question of, is GraphQL dead? At least that's how we're starting things off today. The focus that we had to begin with today is this big kind of overarching question of, is GraphQL dead? But yeah, do you want to give us a little overview of what we're going to be talking about, kind of what our focus is going to be for this part?
Absolutely. I think we're coming up on the 10th anniversary of the GraphQL spec being open sourced pretty soon. I think we've got another few months. And in the recent few weeks and months, it's just been a lot of doom and gloom loop stories about GraphQL, how it's working, how it's not working, and just a lot of people weighing in on if it's time to pronounce GraphQL dead or not. A lot of interesting conversations on avenues like Hacker News and Reddit. So we thought it'd be a good way to kind of just talk about what we are seeing at Hasura, given the fact that we work with lots of different kinds of companies, independent developers. Um, just a good way for us to kind of talk publicly about what we're seeing, what's happening to GraphQL, where it's headed, and just generally the space of API development. So that's exactly what we're going to be talking about.
Yeah, I'm here on audio.
All
Once
right.
my Zoom decides to stop not responding to me, then on my desktop, then I'll join in with my camera as well. But we can get started.
All right, Tanmay, let's get this started. And let's take the question head on. Is it dead? Is it alive? What's going on with GraphQL?
Yeah, I think we've kind of always had the idea that GraphQL it's a complex technology that needs uh, that that needs to kind of be provided in a managed way, right? Like GraphQL is not easy to build and maintain, right? And it is challenging. I remember uh, a few years ago when we looked at GraphQL and we looked at the GraphQL specification for the first time. I remember a bunch of us looking at it and saying, "Wow, this is super complicated. I have no idea how somebody is going to actually be able to implement this because building this seems to be as complicated as building a SQL server, like a server that speaks SQL, right? You have to build up. It's like usually you just build APIs and API endpoints, but now you actually have to build a parser and do query planning, right? Like you have to do these kinds of things that you usually don't. You usually assume that you don't have to do as a part of API development.
Right.
And I think it's like that is kind of the frustration that we're seeing in the community, right? In how in how GraphQL is being used. So that's I think like what we are seeing now. When we if like the precise question, is GraphQL dead? Well, no, it's definitely not dead. It's being actively used, right? Like um, we see that with Hasura users, we see that with other folks kind of building with GraphQL. Um, but I do think that I do think that like GraphQL has to be invisible, right? Like when you're using GraphQL, anybody who's successfully using GraphQL should not be talking about GraphQL. And I think that is the failure mode for GraphQL. I think when you're
Hmm.
using GraphQL, like this is one of the things that the Facebook creators would say. And in fact, even if you go and talk to engineers at Facebook and you're like, hey, so what's your GraphQL story like? Like, how are you using it? How's it evolving? How's it changing? And they're like, what? What GraphQL? Like, no, it just works. We write
I,
some
I
code.
I know what you mean that way because you and I have both spoken to like hundreds of companies, Hasura users, non-Hasura users who use GraphQL, and not one of them weighs in on the many threads that we see on Hacker News, right? So clearly these folks are doing something else, too busy doing something else to be participating in flame wars on Hacker News and so on. So what are these like? I mean, from your vantage point, what are these teams that are using GraphQL successfully, how are they doing that? Like how are they succeeding? And in other words, what's a good way to use GraphQL?
Yeah. So the idea is that the benefits that GraphQL provides technically, right, which is you have overfetching, underfetching, type safety as kind of two big aspects of the GraphQL benefit. And then that kind of the other aspect, which is, fragments and co-locating data and UI together. And GraphQL as a protocol is the only protocol that allows for that to truly happen with things like fragments and fragment fetching and refetching and node IDs, right? Like that only happens with the global node ID and whatnot. That only happens with GraphQL. That part is unique to GraphQL and is not in other places. But that said, the front-end ecosystem itself is evolving so quickly that it's been really hard for that pattern to truly emerge, right? A lot of people use fragments for reuse, right? Like, oh, we've written a part of a query, let's reuse this part of the query. Fragments were explicitly designed to not have to worry about reuse. Everybody could kind of declare their own fragments multiple times wherever they wanted in their code, and that would automatically be deduped into a single query and a unique fetch with masking, right? So those are kind of like the technical reasons that you want GraphQL, right? Now, a successful implementation of GraphQL is where you get these benefits without ever having to worry about how GraphQL is set up, how GraphQL is being used and stuff like that, right? And all of those flows of GraphQL are not, for example, schema-driven GraphQL. They are more kind of implementation-first GraphQL. So the idea is that I'm writing code, that code is creating business objects, that code is creating business methods, and they are showing up in GraphQL. And so you're kind of you're iterating on your domain, and GraphQL happens, right? Then you have client-side tooling where you're generating your you're generating kind of the types from your GraphQL schema, and that client is kind of getting auto-generated and is showing up as and is available for use, right? And as consumers, you use GraphQL, but it's very simple to use GraphQL as a consumer, right? Like none of the GraphQL consumers are complaining about GraphQL as much, right? Because for them, the experience is great. You go to Graphical, you go to the Explorer, you check out what the GraphQL query is, and you start using it, right? That part is not terribly hard, right? That part is easy even to get started with. The advanced stuff is a little bit harder, but that part is still relatively tractable. On the server side, right?
Tanmay, you're describing what Nick Schrock said is that scalable asynchronous business domain layer on top of which GraphQL was a thin abstraction. Is that what you're getting at? Like this powerful data API layer that needs to be present for GraphQL to even be a thing?
Exactly, right? And so when we kind of talk about the fact of like, wait, why are some people able to just get GraphQL? And I would say that some people here are the few people who are kind of doing this domain driven, even if it's consumer driven, even if the consumer says I want these methods and these objects, you go and iterate on the domain. So these folks, like say for example Facebook, other people who've built, like say for example Goldman Sachs, right? Like people who've kind of built these GraphQL implementations which are kind of derived from the underlying domain, all Hasura users, right? It's all kind of domain driven when you're using Hasura, right? The reason why it works, the reason why this approach to GraphQL works, where you don't think about GraphQL too much, it just is invisible that works, is because of a data access layer that can handle the demand that GraphQL puts on it, right? Because GraphQL's execution model in how it will be used and invoked is complicated. It's not a fixed set of things that will be asked for that you can hard code, authorization and the perfect kind of query and all of the, you can't hard code any of these things like you could with REST API endpoints, right? Because for each endpoint, you can hard code exactly the query plan, the fetch, and what you need to do. So it needs this data access layer to exist. And in all these conversations that have happened with like, hey, GraphQL is too complicated and it's hard, you'll notice that like the kind of OGs of GraphQL step into that conversation and they talk about the fact that, hey, yes, we agree with you, GraphQL is hard. And, honestly, it wasn't hard at Facebook because of this amazing asynchronous, parallelizable data fetching layer where we did not have to worry about the fact whether data was coming and was getting joined or not getting joined, and it just worked, right? And that was another team's concern, to make sure that the data access layer is performant and can handle the demand that GraphQL might put in it.
Right. That makes sense. So tell me, is it the corollary to this, is there some approaches that might not work? I think this has been a pretty innovative space in the last, I don't know, 5 to 6 years. There's been a lot of innovation, a lot of companies, a lot of different approaches to doing GraphQL. So is the corollary to what you just said also going to imply that there are some approaches to which the ROI is not that great and might jeopardize the success of a GraphQL project in an organization?
It's a great question, right? And I think like the implicit thing of what I'm saying here, if a little more controversial, is to say that GraphQL on REST is an anti-pattern, right? And people trying to bolt on GraphQL to REST APIs are in for a world of pain. Like, it's possible to start off that way, but it's too painful. It's too painful for three reasons, right? The first is that you have two APIs to maintain. You have REST APIs and you have GraphQL APIs, right? So now you're literally maintaining two API standards inside the organization. And look, the people and process failures that led to having a good REST API, it's going to show up again when you try to have a good GraphQL API or whatever it is, right? So it's this. So there is you now have two APIs. So now that is a kind of people process problem, right? Then there's a technology problem with having two layers. Two layers are redundant, right? You have two hops. It's double the security issues, double the observability issues, double the performance issues. Now, instead of having one person to blame for a bad API, you have two people to potentially get into a room and have them discuss with each other and maybe put them into a cage fight and say, hey, is it the GraphQL layer's fault or is it the REST API's fault? Why is this slow, right? Or why is this not working? And I think the third thing, and this is, I think, what people are complaining about the most, is that, wait, overfetching, underfetching, type safety is possible to do with REST as well.
Right.
So if we are backend developers and we're full stack people and we're building APIs, why are people asking us to build GraphQL? If you wanted type safety, I'll slam on an open API schema and give you type safety. If you wanted overfetching and underfetching, conventions like JSON API have a neat way. Well, it's nowhere close to as gorgeous as GraphQL, but overfetching and underfetching is technically solved. So I get that it's not aesthetic, but if it works, then why are you making me go through all this pain? And this is kind of where a lot of that frustration is coming from, right? For people who are building GraphQL and REST, right? I recently was in a conversation with an enterprise who'd been building with GraphQL for many years, right? And they were just like, yeah, so our GraphQL thing, it's really hard to optimize performance, and with especially with the REST APIs, and our clients, our consumers are still using GraphQL like they use REST, and they're not really using GraphQL the way it's meant to be. And I'm like, wow, it's been 4 years since you've had GraphQL in the stack, and you're still not successfully using GraphQL. I mean, wow, no technology has been this slow to start, right? Even Kubernetes is as complicated as it is. In 3 months, you figure out whether or not Kubernetes is a thing for you, right? And if it's meant to be, it's meant to be. You don't have this insanely slow phase of knowing that GraphQL is useful for you or not. So I think that's been very interesting to see, right? I think GraphQL on REST doesn't work. I think GraphQL natively on database also doesn't work without you rethinking how you're doing data access. You can't take a Rails app and just start writing GraphQL and connect it to your database. It's not going to work. Because as soon as it becomes you run into real authorization issues and real performance issues, you're not going to be able to optimize it. I mean, or if you do, I mean, you can. It's improper for me to say that you can't. Of course, anybody can. People have done it, and people will do it. But yeah, exactly. But you end up building what people like Hasura have done, for example, GraphQL do, right? Exactly, right? Which is more kind of customized to Postgres, but it's not worth it then, right? Then you're like, wait, what am I what am I doing here? Why am I building this? And why is the one person who knows how to build this, if that one person gets bored of this project and decides to move on, you're screwed. And
Yeah,
unfortunately,
we've
that
seen a
seems
few
to have
of
happened.
those instances as well, right, in large enterprises where I think
Yeah,
if you think through this problem hard enough, you will arrive at the same kind of solution that the Graphas and other domain first graphical approach tooling teams have taken, and then you end up in this
exactly.
position.
Exactly.
That makes
And
sense.
the good news is if you do it right, it's actually faster than REST, right? Like you can get to a place where it's faster than REST, right? A very, very simple benchmark to do that you can do instantly is like just fire up a Hasura GraphQL, fire up a REST API that you've built, hand built, right? Whatever. And you make a REST API call. In practice, the benefits that you get are going to be so much better performance-wise with GraphQL because of projection pushdown. So when you make a REST API call and you have 100 attributes, it's
Right.
you get 100 attributes, right? In fact, even with JSON API filtering, if you decide that I only want to do like 3 attributes that you fetch, you do that. But then in that REST API, when you make a call to the underlying database, in the way that you use your ORM, you likely end up fetching the whole object with all the columns.
Yeah. Yeah.
You will not, like, it's quite painful to parameterize what columns you fetch inside with the ORM sometimes, right? Like it depends. I don't want to generalize this, right? But it starts to become painful to bring the selection set that the user wants into your kind of data access layer, and it starts to become painful. I mean, you have to do work to do it. So the out of the boxness, when you spin up Hasura GraphQL, you'll notice that it's doing exactly the right thing with the database that you would have if you had really sat down and optimized just that particular request, right? So that's the good news. But I think like a lot of people who using GraphQL are kind of setting themselves up for failure.
We've seen some of the stories, and generally takes a couple of years to kind of turn those projects around in large enterprises. So good luck to those trying that out. Then, just in the interest of time, quick final soundbite. Where are you seeing GraphQL headed? What's next for it? It's clearly not dead. Where would you like the community to kind of go?
I mean, I think that something that we are trying at Hasura and that I hope becomes a better thing over the next few months and years is GraphQL for solving a data access problem, GraphQL for solving a unified semantic layer problem, right? GraphQL for really helping you think about the fact this is an opportunity for me to provide generic, flexible, secure, performant data access, right? This is actually the problem that I want to solve. And if I solve this problem, so many things will become easy, right? That's, I think, the direction that I see for GraphQL that I want us all to do at Hasura, and that I like to promote in the community outside, right? And I think it's particularly relevant and topical in the context of the of AI that is to come, and which will, I think, perhaps set us up for some of the next sections in the call today.
Excellent. Thank you so much, Tanmay. Rob, over to you.
Thanks so much, Sandy. Thanks so much, Tanmay. That was awesome. I'm gonna see if I can have some kind of trouble with my video here, but we'll just keep moving through, so no big problem there. Next, I'm going to bring up Akshaya on the stage, someone who has been here many times with us before. He's going to be talking to us about GraphQL and federation features inside of DDN. So Akshaya, do you want to join me on the stage, please? Hey, how are you?
All right. Hey there. I'm good, thanks. How are you?
I'm doing well, and I know that federation is a big topic that we had in V2, and people have kind of been wondering about how it's going to change in V3 with everything going forward in DDN. So I'm sure a lot of excited people to hear about ways of federating with GraphQL and Hasura, so I'll turn it over to you.
Cool. All right, I'm going to jump right into it. So I think with federation, the trick is that at the end of the day, consumers want a single rock-solid API. They don't really want to learn a new API for every data source, every service. And at the same time, you have a bunch of teams that own different parts of the domain. And they're sort of responsible for getting this data to the API. So how do we get both of these at the same time? How do we get a single, consistent, cohesive whole API, while at the same time making sure that teams can can continue to iterate on their own domains. And GraphQL, in fact, was created to solve this problem. So we hit questions like, hey, who owns the federation bit? How do we coordinate changes across teams? Who handles things like failures and rollbacks? And some solutions, well, they might want you to do this, but this is not fun. So some solution might say, hey, every team has to maintain their own GraphQL server, which is tedious by itself. And then have some sort of solution where these GraphQL APIs are sort of smushed together. And then you get a final API. And this sort of solution doesn't work well for a few reasons. One is that as an owner of a particular subgraph over here, as an owner of one of these GraphQL servers, I have to worry about whether names I'm using, whether types I'm using actually conflict with any other team. And if you have a bunch of teams doing this, now I have to worry about a lot of conflicts. And also at the router or gateway layer, composition isn't really a good story. And we'll see some examples later, but and the person doing this composition now has to be aware of the entire API service of all of these GraphQL servers across all of these teams. So Hasura takes what I believe to be a more thoughtful approach when it comes to this. And this entire class of issues, it doesn't happen. This is in fact probably, Hasura probably has a better model when it comes to this. So this is sort of our goal, that every team that owns a portion of the domain, which is a subgraph, can do independent SDLC right from development to testing, like iterating on their API, iterating on their portion of the domain. And when they're done, they can take it and they can deploy by themselves. But all of this happens in the context of the Supergraph API. So how do we make this happen is the question. Well, we've seen what a supergraph looks like. So this is a model of the supergraph. So you see that there are different models and they're all connected by relationships. And so we have metadata that defines this supergraph. And what we can do is we can say that we're going to split this metadata into different subgraphs. And each team owns one of these subgraphs. So each team owns a portion of the domain. Now, the key thing here, which we're going to come back to again and again, which users of Hasura know, is that these things define models and relationships instead of thinking in terms of GraphQL fields and resolvers. And this turns out to be the right level of abstraction when you want to do federation. So the subgraphs here are proper graphs. They're not GraphQL servers. When you put subgraphs together, you get a big graph, which is a supergraph. With a single repository that contains the whole supergraph, you can just take all your subgraph metadata and create your supergraph build. But then a team in a federation context, a team A, let's say, that owns the subgraph A, they can split off their metadata into only that subgraph's metadata into a different repository. And what they can do now is they can create a subgraph build, which is based on only the metadata for that subgraph. And this subgraph build doesn't actually serve an API, but it is a representation of the metadata. And just like supergraph builds, it's immutable, and it has this unique ID. And then what we can do is team A can go off and they can create their own subgraph builds for their subgraph. Team B can do this for subgraph B. And then when team A wants to sort of test their API, they can take their own subgraph build and they can pull subgraph builds from other teams and they can build supergraphs, which means they can now test their own subgraph in the supergraph context. And then they can continue to iterate on this. They can continue to create new subgraph builds and then sort of continue to create new supergraph builds based on that and iterate on it. And then once they're done and they say, hey, this is the subgraph build that I want, they can take that same subgraph build and they can deploy it to the project URL, which is again just composed of different subgraph builds. So, all right, this is cool. But why is it a good story? Well, here's why. When we're actually composing subgraphs, we get a bigger graph. So the model we're thinking of is actually taking models, relationships, and sort of putting them together. So this is a model based on composition of graphs. It doesn't want to couple different GraphQL APIs. And this is what makes it a completely a far better model. So let's look at some ways that sort of benefits us. So whenever we build one of these supergraph builds, right, what the build time is actually doing is it's validating all of these models and relationships in the complete supergraph context. So even if you have relationships that are spanning different subgraphs, they're all validated correctly. Also, because the whole supergraph is validated in one time at build time, you're immediately notified of any problems with GraphQL, namespace types, field name, these kind of conflicts, and you can sort of resolve them at that point. Again, this is possible because we're dealing with models and relationships as our fundamental sort of modeling unit. Let's see. Composition. The story for composition is far better than other solutions allow. So here's an example. Let's say you have different subgraphs. This is an e-commerce application, and one team owns the user model, a different team owns the reviews model, and a different team owns the purchase model. So just with these models and relationships set up, you can do things like get me all the users who have a certain number of purchases, but then sort them by the number of reviews they have in descending order. And what this is doing is a bunch of cool things. So it's not just joining based on these relationships, but it's also aggregating across based on these relationships, and it's also filtering based on these relationships. And so composition works exactly the same. This is as good as having different tables in a Postgres database, and that sort of flexibility that you get, but across all your subgraphs and across all your data sources. So you can join, filter, and aggregate across these relationships. Because at the end of the day, the engine actually just runs the supergraph. So if you look at the engine as sort of this query planner, it's sort of optimizing across all these models, across all of the subgraphs and data sources. Let's see, performance. Now, because the engine is actually running the supergraph build as a whole, and not really worrying about, there's no extra hop to get to a subgraph, which means performance is automatically that much better. Also, because the engine sees the entire supergraph at one shot, we can do performance optimizations that other people simply cannot. Like we can begin to have much better query plans, or we can begin to parallelly fetch data to actually satisfy that query. Okay, so let's say as a consumer of the API, you found a bug or you found a performance issue. What do? Well, with Hasura, because the entire thing is based on models again, because the supergraph modeling, you can come back to the Explorer and you can actually see different models, which data source they belong to and which subgraph they belong to. For example, if I click on products, it shows me, okay, so this is part of the experience subgraph and database one, which means as a consumer, there's a great degree of transparency, and I can immediately go and talk to the right team. And the granularity is down to the database. So this is cool. Let's see. Query plans and tracing work across the whole supergraph. So I think when it comes down to it, yes, and we're building more tools as well, like schema registry and schema diff. The build time validations is already going to take care of a whole class of problems, but you can also do checks at the schema level, the GraphQL schema level as well. So I think federation is an interesting segue for today, because is GraphQL dead? Well, clearly not, because GraphQL works phenomenally well, I think. But at the same time, the cool thing with Hasura is you're modeling your data domain. And this is one of the things I love about Hasura. Because when you're modeling your domain, when you're thinking about things in terms of the data models, in terms of the relationships between them, you're not really worrying about the tedious details of building out things like GraphQL servers or an API server or fields and resolvers. And that sort of repetitive stuff is taken care of for you at a in a way that's far more performant and expressive than what you'd be able to handle. So hey, your supergraph can serve GraphQL today, but tomorrow maybe it serves gRPC. Maybe that same supergraph could serve SQL. Maybe it could serve REST. And that's cool. And now that you can sort of bring all your data to your supergraph with and parallelize that effort across all your different data domains with different teams, what cool things can you do with it is probably the next question. So you can read more about this at supergraph.io. That gets a lot of the details about supergraph architecture for federated data access layers. So please do check that out. And all right, we'll be rolling this out over the next few weeks. So do watch out for that and let us know what you think. All right, Rob, back to you.
Shaya, thank you so much. And sorry for not catching you with your screen share earlier on, but we'll have these resources available for everybody where they can go back and view this, and then also the deck as well. So thanks so much for paving the future for us there for something possibly beyond GraphQL. Who knows? Thanks so much.
How's it going?
Doing well. For those that were on the community call last month, we had hoped to be able to talk about this RFC during that call, but we ran out of time. And we joked with Abhinav about doing like a Jimmy Kimmel, Matt Damon thing where we always invite him to be the last segment of the show and then just push him off to the next one each time. But we decided to make him a priority this time so that he can go ahead and present this information. And he's going to stick around for the last piece that we're talking about, which I'm sure a lot of people are going to have their minds blown by and be very excited by. So Abhinav, I'm going to turn it over to you.
So hey folks, I'm gonna talk to you about this RFC on what is the biggest expansion to the authorization system in Hasura since it started. And as you might already know, today Hasura uses role-based access control, where you define a certain set of roles, and for each role you customize for every sort of table and column in Hasura, like what are the permissions, what columns is this role allowed access to, and which subset of the rows this table is allowed access to. However, in like real world like authorization systems, it's not always possible to capture all states as separate roles. And even if you like sort of like explored your set of roles and modeled it that way, then it's not possible to reuse permissions because a lot of roles will have a lot of overlap in what permissions they have. And for complicated permissions, it's also like very hard to verify, like given a set of permission definitions, like is this correct, is this not correct? If I change this bit, like is something going to break, is not going to break? And so this RFC proposes fundamentally moving from like role-based authorization to what we call rule-based authorization, where you define small units of authorization rules, which can all compose together to form a complex authorization model. This is like a strict superset of like role-based authorization. So like if you are already doing role-based authorization today, like nothing changes. It like just very easily fits here. And like over time, you can start expanding the scope of your authorization system, keep simplifying it, and like have role-based, attribute-based, everything combined together. So let me just give you like examples of how conceptually a very simple like authorization scheme gets complicated with role-based access control, but in the new model, it will be like very simple to implement. So imagine like I have an internal API that's targeted at my company's own developers and support agents. So I have a table for my users, which have like these columns: ID, name, email, isgov, which means like whether the user is a government user or not. I have a record of any user activity, and I have some support tickets that have been assigned to support agents. So, and like I said, I have two personas here. One is like my company's own developers and my company support agents. Developers should be able to view all user information. Support agents can only view the data for users for whom they have tickets assigned to them. And some user information is protected. For example, like PII fields like name, email are protected unless like the specific person who's accessing this API has access to PII fields. Similarly, government user data is restricted unless the API consumer has explicit access to government data. And so this is like a simple system to understand, but like modeling it in rules with roles becomes like pretty complicated, because one, I have to capture all these possible states as roles. So I'm going to have a base developer role. I'm going to have a developer with PI access role, Gov access role, with both PI access and Gov access, and similarly for like support agents. So I have 8 roles, even though like realistically I only have 2 personas in my company, with some more attributes apart from that. And now when I actually go and try to define permissions for this, it just gets very, very complicated. So for column permissions, what in Hasura v3 we call type permissions, it's very similar to permissions, but like I have to spell it out separately for each role. And at the row level permissions, which what we call model permissions, they get even more complicated. So here, like I did not have the energy to like list it out for all roles. So for a subset of the roles, like you said, like, hey, developer base is allowed access if it's not a government user, which is not like a very idiomatic way of thinking about it. Like to define what is a minimal set of permissions, you have to think about what this person is not allowed to do, which is like very unintuitive. Similarly, with government access, filter is null. Now imagine tomorrow I restrict my access with some restrict like access based on some other attribute. I will have to go and figure out like, hey, is this null? Does that actually mean allow access to everything? Or does it mean allow access only at that point what access is allowed, and now change it? Like, it's just very complicated to reason about and manage. And similarly, like if I go from like users to user activity, I have to like duplicate a lot of the same permissions again. Like I know my user which don't have Gov access allowed, for those user activities should not be allowed. So like it's just like a giant web of permissions, which like is very hard to reason about. So what we are now proposing in the new system is that you can have just two simple roles, developer and support agent. This is what your real roles are after all. And you can have some extra claims or session variables like injected by your authentication system, which can say like, hey, does this person have access to PII, and does this person have access to Gov users? And in your permissions, you are just now going to define very simple rules, which will all compose together automatically. And this is also like the natural way you would think about it. So for example, for my type permissions, what I would say is that, hey, allow the field ID to be accessed by everyone, because I know it's not a sensitive field. Just allow access to everyone. I don't want to spell out who and when. Just allow it to everyone. The other thing I want to say is that, hey, name and email fields I know are PII fields. So allow access only if the PII access is set to true. And that's it. This is like, I'm done with my type permissions. I don't have to mention roles at all. Because like it's really not about the roles which fields are you allowed access to. It's about like whether you have a certain attribute set or not. Similarly, my model permissions get like vastly simpler. For example, like I want to say like, hey, developer should be allowed access to all users by default. Great. So I just say, hey, if role is developer, allow access to everything. Then I say like support agent should be allowed access to users they have support tickets for. So I say like, hey, if role is support agent, then look at the tickets relationship, and if the agent ID is like whatever my actual agent ID is, allow access to those objects. And then I know like, hey, there is this little like rule about Gov users also. So I'm going to say like, hey, if the user is a Gov user, and if the person does not have Gov access, deny those objects. I don't have to think about like what roles, what other access they were granted and whatnot. I can just define this like simple rule in isolation, and it composes automatically with all these other rules. And so now this is like a cleaner way to think about it, cleaner way to understand it, and like more like robust overall. Similarly, like another sort of primitive you're adding is like being able to like refer to other like your related object permissions inside a particular like model. So for example, like I have already defined a set of permissions for users. For user activity, I know that like if I have access to the particular user, I also should have access to the user activity. So all I define is like, hey, allow user activity if I have access to the user. And that's all. I don't have to duplicate all the permissions all over again. But like, let's say maybe like some activity has been explicitly hidden by the user, and I don't want to allow access to. So I define another simple rule saying that, hey, deny objects where like is hidden is true. And it all just composes automatically instead of having like these giant complex permissions per role. So yeah, this is the RFC in a nutshell. There is a lot to unpack here. So we'll share the link of this PR with you. It's a PR on our open source repo, and you folks can like ask questions, give feedback, see if something doesn't check out for you guys, or if you'd like to see something more. And yeah, this addresses a lot of open GitHub issues right now. But yeah, that's about it.
Abhinav, that was awesome. Thank you so much. Some really exciting things in the declarative metadata syntax that make a lot of us excited about writing some really easy authorization rules. So thank you. As a reminder, we have our Discord office hours every Tuesday at 10 a.m. Pacific. We also have a Discord server which you can join and stay up to date on everything that's happening with DDN. As always, we're looking for feedback, and if you're interested in doing a community demo, please let us know. We'd love to showcase you on one of these calls, especially when we have a bit more time in the window as well. But otherwise, we will see you folks at the next one. Thanks.